card 34. For this problem, you need to know how to work with negative exponents. And you need to know what that means when you're dealt with a fraction and there are some negative exponents on the variables. And that is something that it is advanced. So if you have not dealt with this at all, then I would speak to your math teacher about if you'll be able to learn it in time for the test, or if it's more of a question that you might want to skip. But if you have seen it before, then definitely watch this video and get a refresher on what to do when you're dealt with these negative exponents.
We have 18x to the negative 2, y cubed, z. 3xy to the negative 2, z squared. So when we're dealing with negative exponents, it just means that they belong on the other side of a fraction. It means that they'd be happier being positive on the other side. That's kind of what it means in a very simple sense. So let's rewrite everything, but we're going to put anything with a negative exponent as a positive exponent, but on the other side. 18 is good. We'll leave it right where it is. So I'm just going to go left to right, and we'll kind of combine and reduce after. So 18 we took care of. X to the negative 2, that would be happier on the bottom as a positive 2. X squared. Y cubed is happy on top because it's positive. Same with z. So really we're only moving things that are negative, okay? 3 is happy on the bottom. X is happy on the bottom. Y to the negative 2 isn't. So we want a y squared on top. And a z squared is good on the bottom. All right, so now let's start reducing. On top we have an 18, we have a y cubed and a y squared. Together that is 5, y to the 5th. Because when you're just multiplying with the same base, you add the exponents. So 3 plus 2 is 5. And then we have 1z. On the bottom, let's put the coefficient first, the 3. So put a 3 here. We have an x squared with another x. And x is like x to the 1. So that's x cubed. And then we have a z squared. Now we have to start reducing. So anything that's on the top and bottom, we want to kind of reduce and make sure that there's only one of each variable. First thing with the numbers, we have an 18 and a 3. 3 goes into 18 6 times. So we can actually just get rid of that 3 on the bottom and leave it as a 6 on top. Now, y to the 5th. This is the only case where there's a y. There's no y's on bottom, so we know that the y to the 5th is fine where it is. Z. There is a z on the top and a z squared on the bottom. So what you do here is you take the larger exponent and you subtract it from the smaller exponent. In this case, this is z to the 1. And you leave it wherever it's larger. So if there's one z on top and a z squared on bottom, then we're left with one z on the bottom, because 2 minus 1 is 1, and then you leave it wherever the larger exponent was. So we have 1z, or z to the 1, or just z on the bottom. All right, so the z's are taken care of, and now we're just left with this x cubed on the bottom, and there's no x's on top, so that means it's fine where it is. All right, so that's really how you're going to work through these sorts of problems where you're just simplifying. And I'm just going to write it a little bit cleaner over here. 6y to the 5th over x cubed z. That is our final answer.